The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Standard hydrogen electrode. Great. The standard hydrogen electrode can be the cathode, or it can be the anode. When it is the cathode, right, that's when we'll see reduction taking place, and we'll see 2 hydrogen ions plus 2 electrons giving us hydrogen gas. And that again is going to give us a standard cell potential of 0, right? And that was arbitrarily assigned, as we had previously mentioned in the lecture. Now at the anode, we're going to see oxidation take place, and we're going to see our hydrogen gas is going to be oxidized, right? And it's going to give us 2 hydrogen ions plus 2 electrons. Wonderful. Now if let's actually take a little bit of a deeper look into the workings of the standard hydrogen electrode. Okay, great. So we see here that hydrogen gas, right, at 1 atmosphere is going to be bubbled through a 1 molar hydrogen ion solution, as we see here, right? Okay, and what ends up occurring is there's also this piece right here, and that's going to be your platinum electrode. That platinum electrode is actually going to be inert, and although it's inert, it still serves 2 very, very important functions. First, it's going to be an electron conductor, right? Secondly, the surface of it is where our hydrogen ions are going to be reduced, and the surface is going to be where our hydrogen gas is going to be oxidized. Now, let's actually take a look at that reaction on the surface right here. Wonderful. So we have our electrons, right? And we take our gas as such. Oh, that is not what we were trying to draw. Okay, we take our gas now, right? When our gas is going to be oxidized, that will lead us to our hydrogen ions. Right? Great. Now, let me just write this a little neater here. Now, when our hydrogen ions are actually going to be reduced, right, that reaction we can also just showcase here as well. Be going that way. Wonderful. Okay, let's build on this, and we'll actually do a little bit of an in-depth example on our next slide. Just a side note though, just for you guys to keep in mind, just remember when you're doing calculations for your cell potentials, that let me just show you here that the stoichiometric coefficients, as you see here, they're not significant, so you do not have to include them. Okay, great. Now we'll take a look at sorry, just get my pointer here, at standard hydrogen electrode as an anode. Okay, great. What are we being asked here? For the given reaction, depict the anode-cathode half reactions, electron flow, and find the expected reading on voltmeter. Okay, great. Let's take a look at our reaction here. We have hydrogen gas here, right, plus the copper ion giving us 2 hydrogen ions, right, plus copper solid. If you look at the oxidation number of our hydrogen gas, right, it goes from 0 to +1, and then our copper is +2 to 0. We see that it's actually our hydrogen gas here that's going to be oxidized, and it's our copper ion here that's actually the copper here is going to be reduced. And remember, we said in the previous slide that oxidation occurs where? That's right, it occurs at the anode. And the reduction takes place at the cathode. Thus, we know that if this here is our hydrogen electrode, we know that that's where oxidation is going to take place, and thus this will be our anode. In case it wasn't given to you and you had to deduce that yourself. And here is our cathode. Okay, great. Now, before we move on, let me just quickly take a look here at our salt bridge, right? This is a strong electrolyte here. We're working with, let's just take a look at the entire setup actually before we proceed further. Here we have our standard hydrogen electrode, half cell. We have another half cell over here, right? And then this is going to be our salt bridge. And in our salt bridge, we have sodium nitrate, right? And the sodium nitrate is a strong electrolyte. If we like, we can even write it. And what does strong electrolyte mean again? It means that it's virtually going to completely dissociate. So we can go ahead and just, when we even write it, we can just write it in its dissociated form. Perfect. All right. Now what ends up occurring here, if we take a look, is we also have a voltmeter, right? And this is going to be the conducting wire going through it. Wonderful. And this half cell here is going to have a 1 molar nitric acid solution in it. And this half cell is going to have a copper nitrate 1 molar solution in it. Okay, great. Now we've labeled our anode, we've labeled our cathode, right? So we're done that part of the problem. Next, we're being asked to do our half reactions. Okay, so let's take a look at the half reactions taking place here. The first half reaction that we're looking at is the one taking place at the anode, and that is going to be our hydrogen gas going to our hydrogen, it's going to give us our hydrogen ions here plus our 2 electrons. That's going to be the oxidation reaction there. Now the reduction reaction we're going to see here is going to be our